I'm Kurt Schwader, your moderator, with today's speakers David Merrill from Polarion, Jessica Jacklin from Clockwork, Arthur Hicken from Parasoft, and Ashish Kuthiala from Electric Cloud. Today's schedule consists of 50 minutes of presentations, leaving about 10 minutes at the end of the hour for audience Q&A. Before we begin, I'd like to run down some features of your audience console. First is the Enlarge Slides button. This button will maximize the slides to fill your entire screen. The Download Slides button will download and print the slides if you'd like a hard copy to follow along with. The button labeled Forward to a Friend enables you to send an email to someone that will include a registration link to this eCast so they can also attend. The Ask a Question text box enables you to participate in today's event. You simply type your question into the box and submit it using the Submit button. You can submit questions at any time during the presentations. We encourage you to do so early and often while you're looking at the material in question and it's fresh in your mind. We'll address as many of these questions as possible during the closing Q&A, and if you have a question pertaining to the eCast operation itself, you can submit those too, and one of our technicians will be happy to respond to you during the eCast. There will also be a closing survey at the end of the presentations today, so please take some time to fill those out. It's a very important and critical piece to provide your input to these companies as well. If I were to sum up automotive systems development, I think it can be done in two words: complexity and reliability. There's a pressure for increased software in automotive systems today, not just the infotainment systems that tend to be multimedia oriented, but also things like powertrain, braking systems, and fuel injection systems that have high reliability and mission critical requirements. Of course, all of these have to operate flawlessly over large temperature ranges and high shock and vibration. All of this complexity really adds up to a lot of challenges to auto systems developers. In addition, you're able to plug in things into your car these days via USB inputs or smartphone connectivity. A lot of these capabilities are introducing the risk of purpose-built attacks that typically are found on your PCs or what have you, but now can be targeting things on your car. And referenced here with some of these tests that were being done where people were actually able to use malware to literally shut off car components, kill engines, and release or slam brakes really is eye-opening and needs to be addressed today. Finally, errors are costly, and recalls and bug fixes are costing the automotive industry billions of dollars a year annually. Today, we're fortunate to have 4 experts in various aspects of automotive design who will share their insights about these requirements. We'll start with David Merrill. David is a system engineer at Polarion and works with U.S. and global customers and prospects implementing product development Q&A solutions using the Polarion Solution Suite. He conducts frequent global seminars and training in application lifecycle development, best practices. Prior to joining Polarion, David led Phoenix Technical Consulting Group for 6 years, where he developed and implemented software and solutions in cybersecurity and ITIL configuration management. David, the floor is yours.
Thank you very much, Kurt. It is a pleasure to address you today, and I'm grateful for the opportunity. Polarion was founded in 2004, and application lifecycle management is our center of excellence. It's not about proofing code, but ensuring that the code that is created fits and traces within all the robust development artifacts that are required to produce the world's products and services. Polarion ALM has a great appeal to automotive customers today, primarily because it is a heavily regulated industry. And some of the customers that you see here are really on the cutting edge of automotive solutions, producing hybrid vehicles, fuel cell technology, and even precision agricultural vehicles. Polarion is certified as a trusted tool by TÜV Nord, where it has achieved ISO 26262 and IEC 61508 compliance. I am in violent agreement with Kurt's initial introduction. The complexity in the automotive industry is growing rapidly. As a system engineer, I work with customers to implement around these needs. But I have a practical example too, because I put myself through college as a mechanic. So if you looked in my garage, you would find an old Ford pickup truck being rebuilt from the ground up. But the most complex electrical system in that car might be a capacitor or ignition coil. There is no ECU. There is no line of code. It's entirely serviceable. And I contrast that with working on a modern vehicle where I have to plug in diagnostic equipment to receive codes, and I have to contend with software which for me in many cases is a black box, unattainable to me as a mechanic to change. So this increase in millions of lines of code and the complexity of software integrating with both the electrical and the mechanical systems of a car is a formidable issue. And it's not just for mechanics and users and operators, but not all manufacturers transition well from the electromechanical manufacturing process to full mechatronics, which combines the disciplines of software engineering with electrical and mechanical engineering, and must also necessarily impact business and marketing concerns. As an example, Ford Motor Corporation fell from 5th to 23rd in overall quality according to J.D. Powers in 2010. And the New York Times reported that the sole reason for that was in the difficulty of the software interaction on their dashboards and had very little to do with the overall mechanical reliability of the vehicle. So I'm sure many of you know as well, or perhaps even better than I, the major challenges in software-driven electronics. We're now combining the user and operator with the operation of the vehicle. And many of these new functions have safety impact. So there's an increasing need to achieve risk management to eliminate or mitigate risks to the point where there is an acceptable residual risk and the operator can be involved in that relationship. We need to be able to achieve the necessary standards and compliance of regulatory organizations, as well as implement suitable methods for the software development to operate side by side with the mechanical and manufacturing processes. As an example, this modern vehicle that I work on has a particular mode called fail-safe mode, that if the electrical system starts to fail before the battery drains or the alternator ceases to function, the operator is notified and the vehicle automatically slows down so that the vehicle can safely get to the side of the road before complete electrical failure. In a modern car, complete electrical failure can have serious, even life-threatening risks. So the software side of this vehicle can control the detection and occurrence of this serious failure and communicate that to the operator. The Polarian solution to these problems is really to establish the need to organize this multiplicity of mechatronics requirements, design and risk artifacts, as well as coding artifacts, so that the relationship between all of these becomes highly configurable. And in fact, in Polarian, we refer to them as work items, which can be as simple as a business case or as detailed as a software code or class that is implemented in ECU firmware. We hear our customers tell us the need to have instantaneous traceability, that instead of maintaining stale documents on file systems and having to correlate them periodically, the need to have demands for this traceability to be always accurate, always available is very high. So we need to be able to establish that also with the historical traceability, so that not just we can view the current results, but we can forensically examine the evolution of a requirement or a design or the change history of software as it's released and how that impacts the rest of the product development. Ultimately, our goal is to be able to validate requirements to cover not just the breakdown of the design, but also to key tests, to ensure that those test cases are visualized, approved, and executed with each and every release. You can just ask Toyota the impact of missing perhaps one test case when a vehicle is released. The cost of recall and the cost of loss of business due to public image is a very serious concern. And then on top of that, these other risks come together to jeopardize the safety of the vehicle. And so we need to make sure that safety hazards or FMEA risk don't exist as spreadsheets that we analyze, but are integrated into the product development structure just as easily and simply as software code. In the Polarian solution, we need to be able to implement and import and organize information easily. Take these stale documents that exist on your file systems and break them down into content that is available as work items and traceable throughout the product development cycle. Additionally, we can make this information still viewable in easy-to-read document-like views. In the Polarian solution, the configurable roles between these artifacts support a many-to-many relationship, not just between work items in a single component or a single project, but across the entire landscape of the product development cycle. These configurable link roles can be viewable individually or as formal reports of traceability across a component or product. The Polarian solution provides the instantaneous traceability so that as I create requirements, when they're available, other stakeholders in the process can operate and act on that requirement, breaking it down into individual disciplines and components, as well as creating test cases and control the tasks necessary to produce this. And at any time, the impact of change can be visualized through this traceability. In addition to the traceability between artifacts, I need often to be able to tie this traceability not just to an instance or the latest revision of something, but to a particular point in time. So as I create key test cases and requirements while product continues to evolve, I need to be able to establish these relationships to that point in time and always be able to answer the question, who made a change, when was that change made, and what is the content of that change? The Polarian solution also requires or allows you to introduce the safety hazard and FMEA risk artifacts into the product development cycle. That means that as different requirements perhaps cause a particular risk or hazard, that can be built into the traceability and structures within Polarian. Then the actions that we take to mitigate those hazards, which might be new software code, it might be modifications or change requests to existing code, or it possibly could be information to the operator or the manufacturer of that particular item, are well configured and well communicated throughout the entire process to result in not just the initial statement of risk, but the residual statements after the mitigation is complete. So that behind the scenes also operates a Polarian workflow engine, which makes sure that all of our processes and policies are enforced as the product evolves to ensure us ultimately that as we produce the world's products and services, we will always be able to ensure that as we release product, as software is released, as hardware and components are released to OEM manufacturers, as we receive things from suppliers, that they meet the standards that we've established for both electrical, mechanical, and software production. So I'd like to thank you very much for my opportunity to speak to you today. I would encourage you to take a look at the functional safety white paper available on the Polarian website. And with that, I'd turn the time back over to Kirk.
Great, thanks, David. Our next speaker is Jessica Jacklin, Product Manager for Clockwork Insight, and sets product direction for them. She joined Clockworks in 2010 and has over 10 years of experience in related technologies. Her background includes experience in software design and development, consulting, training, and support. Jessica is based in Orlando, Florida. Jessica?
Thank you, Kurt. So I guess let me switch to our next slide here. So as Kurt and David had already outlined, vehicles start to progress throughout the years. You can see here that, vehicles started out being more mechanical and then electromechanical and electrical, and now within the past 20 years, cars have evolved to contain a complex network of as many as 50 to 70 different independent computers. And with this becomes increased volume and complexity. And we need to be able to ensure that the software is secure and reliable. As we're progressing here throughout the timeline, more and more things start being added to the vehicle. So our attack surface is growing exponentially over time. We can now get into vehicles through long range, short range, and direct connection to vehicles to be able to do things that we weren't able to do before. As such, safety has become a greater and greater concern. So if we go to the next slide here, one of the things that we can do going forward to make sure that our vehicles are going to be safer overall is the first step would be to be able to identify critical coding errors and vulnerabilities. So 3 of the areas that we can do that with would be making sure that you build in security with threat modeling and defensive coding. One of the goals of threat modeling is to be able to shine a light upon the security risks that may not be obvious or anticipated by the design team. And this information can then be used to develop a risk management strategy and provide a roadmap for future security engineering activities. So we're going to go through, and actually in the next slide we'll discuss a little bit more, but going through this threat modeling process, you can also take that information to begin to drill down and identify specific vulnerabilities that could expose your embedded software to risk. And we can help eliminate some of that through automated source code analysis or SCA tools. One of the other things that we need to look out for is making sure that we address reliability quickly and early. So the longer you wait, the more expensive it's going to be. So I believe the industry estimate says that the cost of addressing a code defect after build is 10 times higher than addressing it during development. And that's why it's extremely important to be able to address reliability early. The third thing that we can do to address some of these problems is to ensure compliance with the latest industry standards. So we can look at making sure that our software meets the MISRA compliance as well as ISO 26262, and we'll also go into that going forward. So if we look at our next slide here, some of the things going into a little bit more detail about protecting against software failure and attack, as we had just mentioned earlier, would be threat modeling. So threat modeling, to build an accurate threat model, you need to be able to identify the security objectives and start asking questions. You know, is the goal to prevent any and all security breaches? Are certain attacks permissible? You know, so it's important to develop realistic objectives when dealing this out so that you know what the cost and effort is going to be. So you need to be able to identify those threats. Also, being able to determine the application's assets. So you need to look at the assets are like prime targets for an attacker, and they need to be protected. So these can include soft assets such as business reputation and customer trust, as well as certain attacks such as an attack on an entertainment system might not present a danger to drivers, but could dramatically reduce customer confidence in a car. So we need to take a look at, you know, which things we're trying to protect and how we're going to do that. Next, you need to be able to identify threats that could impact each individual asset. So you need to take confidentiality, integrity, and availability into consideration when looking at your assets. And then brainstorm these set of attacks to realize which each threat is and how it's going to impact the vehicle. And then also going forward and identifying the vulnerabilities. You know, to apply this in more of an automotive context, so development teams need to be able to consider potential inputs to an automotive software system such as a GPS or Wi-Fi and be able to identify ways in which the software could be accessed and determine which assets are most critical to protect, you know, like the infotainment system versus the brake system. You know, so we need to prioritize those things. And then we also have tooling, which comes into the picture. So you can do dynamic testing, and those tools are really great at finding vulnerabilities. And then we also, you know, such as analyze running an application in a sandbox, exercising catalog of known attack patterns, and reporting potential vulnerabilities to the auditor or developers. But then we also have the other side of this, which is static testing, and that's good at actually finding the weaknesses. So from that point of view, we're going to be able to analyze the code as a model, project data, and control flow without even running it. And also be able to exercise a catalog of checkers looking for known weak data flows and report those weaknesses to the developer. So make sure that you pick a tool that matches your expected operational environment and that you're actually meeting those needs. So one of the other things that we can do here is go for MISRA compliance. So obviously it's very important to make sure that you are compliant with MISRA, and MISRA C3 has just been released in March, and so at Clockwork actually happens to be updating everything based on that. And so we want to make sure that whatever tool that you use is using the latest standards and that they have proper compliance verification capabilities. So not only do you need to be able to have checks in here, but you also need to be able to report on it, use the metrics, and export that data and enforce the workflow as well. always start with an incremental approach. If you turn on every single MISRA checker in an application that hasn't been MISRA compliant before, then you're going to get thousands and thousands of issues and may be overwhelmed. C3 actually has an update where you have rules and then categories. So you want to do mandatory rules first potentially and start doing an iterative development to focus on small things at each time instead of overwhelming yourself with everything in the system. And make sure that the developers have the tools necessary to be able to identify these issues as they're actually writing the code. That way they don't have to write it, check it in, and then later on find out there's an issue and come back later on. The sooner the better. As they're writing it would be best. We also need to make sure that we have ISO 262 compliance. So SCA tools can fully or partially address many of the requirements found in Part 6 of the standard. But in addition to that, you need to make sure that the tool that you're being used has also achieved that compliance as well. So some of the parts to the compliance would be you want to make sure that the tool has a functional, that they can provide you a functional safety manual detailing exactly how to use the tool within the functional safety program. They also should be able to provide you a test qualification pack to make sure that you have correct installation and configuration of the software system, as well as recommendations and guidelines on how to audit an existing installed environment for compliance within the safety guidelines. So you should be able to contact that company and say, hey, tell me all the things that have changed within this release, because we need to make sure that your tool is going to be safe for us going forward as well. So there's two sides of that. Also, anyone who if the tool is compliant, they should have their own functional safety manager there as well, who's able to engage you in function safety-related discussions regarding their tool. So in conclusion, if we circle back around to the beginning, as we've discussed, the amount of embedded software in cars, the more that increases, so too does the risk of software failure and attack in the field. We need to address this by, you can do it by using automated source code analysis tools and modeling relevant threats, and to make sure that developers can ensure that their embedded software is secure, reliable, and compliant with the latest coding standards and processes. So we have static analysis tools are going to be able to help your development teams achieve software verification in a timely and productive manner. So thank you very much. I will pass it back over to Kurt.
Very good. Thank you very much, Jessica. Our third speaker is Arthur Hicken. He's the Chief Evangelist at Parasoft. Arthur has been involved in automating various practices at Parasoft for over 20 years and has worked on projects including database development, software development lifecycle, web publishing and monitoring, and integration with legacy systems. Arthur has worked with IT departments such as Cisco, Vanguard, and Motorola to help improve their software development practices, and has taught at the College of DuPage, as well as developing and conducting numerous technical training courses at Parasoft. Arthur?
Thank you, Kurt. And like David, I've found after I've worked with customers for years and years with cars that I'm pretty glad that the car I have sitting at home in my garage is 50 years old, because it's not really subject to any of these kinds of problems. And some of the things that really I like to point out is that the software errors, if you average the problems that you've seen in the news across cars, IEEE estimated back in 2005 it was about $350 per car. So when you add that up, it's really just a ton of money that is being spent on problems. And the really interesting thing, when you first look at it, you think, well, it's a software problem, so maybe my radio doesn't work, or maybe my climate control freezes me out or whatever. But it turns out that software affects really physical, mechanical things in the real world. So, on one end you have the brakes. On another end, because they start to control the way the fuel goes into the engine, you can go, in an extreme case, to a fire. And this was a recent problem that happened. 90,000 cars potentially had this problem, and a half a dozen of them or more actually caught on fire due to a software problem. So the scope of the problem is that it's quite dangerous. And so we ask ourselves, if we have all this software and we have all these complicated systems that we've mentioned, how can I get a handle on this? And the way to really do that is three basic steps. And one is just prevention. And with prevention, the best thing you can do is go after things like static analysis. Coding standards such as MISRA, ISO 26262, are really designed not just to find errors before they get into a car and delivered to a customer, but also designed to find code that is more susceptible to errors. And this is one of the very interesting things, and we'll talk more about that in just a second. Also, any kind of testing tools you can do, runtime error detection, etc., that really help you make sure that the entirety of the code base is covered. Another very helpful thing is to make sure that you have a tool that helps you integrate the results from everything it is that you're testing, so that you can look at a piece of code and see, well, I ran static analysis on this, but it didn't really get the unit test that I meant. Or can I make sure that this piece of code is tied to this requirement and to this test case and to this success? And this really lets you get a holistic view of what's going on, as well as giving you that traceability that can be so necessary when an auditor comes knocking on the door. So I'd like to kind of just touch briefly on the idea of prevention versus early detection. And a lot of people talk about prevention when they really mean prevent something from getting out into consumers' hands. So, you know, with the prevention, true prevention measure, I'd say your car's safe, it's reliable, have a great day, right? On early detection, it's I found the problem, I'm going to have to repair it. It's great if the factory repairs it and I as a consumer never get it. But as a manufacturer, I don't want to fix problems. I want to keep them from occurring in the first place. And so it's interesting because you can use tools like static analysis not just to find early detection, but also actually to help you craft this strategy of a piece of code that will not allow the kind of errors that you're currently finding. And so I want to talk about the relationship of these different kinds of analysis that occur. We have traditional static analysis going back for decades now. A more modern one you've heard discussed now is data flow analysis, also a form of static analysis. And it's great because it finds low-hanging fruit and goes, hey, look, we found not just a weakness here in your code, but we found a way to really exploit that weakness. And then runtime error detection, which lets you say, well, hey, I'm running my test suite, and I pumped in this funny value, and guess what? I made your engine start on fire. So as a simple example, if we take like an uninitialized memory problem in a piece of code, well, runtime analysis will find it if your test suite actually touches that piece of code. The strength of runtime analysis is that it typically finds what you're looking for. The weakness of it is that it only finds it if your test suite is 100% thorough. Now, flow analysis may or may not find a particular uninitialized memory problem, depending on how complex it is, how deep it is within a particular flow, etc. So it's nifty in that it finds some stuff. It's problematic in the sense that it will leave things behind. If you run it and it's clean, it doesn't mean that the software is actually done. Now, this preventative static analysis or traditional or pattern-based static analysis is neat because instead of saying, let me find uninitialized memory or let me find a potential uninitialized memory, it says, I have a particular coding standard that says, write your code in such a way that memory must be initialized. For example, when you declare a variable, you must initialize it at that moment. And if I write code in that way, the other tools will never find anything because it's not even possible. And so this is a thing that people often mistake when they look at output from tools like MISRA and they say, oh my gosh, I ran MISRA on my code, I got 100,000 errors on our project, I'm never going to be able to fix it. And the trick is that if you actually follow the MISRA guidelines, it prevents errors further down the line. It also has another ramification, which is that if you want to get the most value out of static analysis tools, you really need to make sure that you're running them early and often, not as a QA gate, but as part of your development process. So I want to talk a little about the integration of data and traceability. You need to have a system somewhere, somehow, that's tied into your requirement system, your bug tracking system, your source control system, etc. And what you want to do is make sure that as you're running tests, as you're doing code review, that those results not only happen and that you can see that they happen, but that they're literally bound to the code that they're part of. So again, if it comes along to an audit, you can say, hey, I know that these tests are correlated to this particular piece of code, which is correlated to this particular requirement. It was run on this date. It was signed off by this person. and I know that I'm really in good shape. And so it's really great. The more you can tie together, the more information you can know. And it's especially important for a lot of customers are running multiple tools. There was a study done a couple of years ago with MISRA rule sets, and they found that if you run two static analysis tools from two different vendors, that frequently you'll get a much better result than either one of the vendors provides on their own. And so if you have this intermediary system where you can have your tools report, it's nice to say, well, good, I got this code covered by this tool, I got this code covered by that tool, I got this unit test covered by this other tool, and be able to have really great audit reports, traceability reports, but additionally be able to have at a project level the kinds of reports that help me understand how's my project doing. Because the questions I ask when I'm managing a project are, is it on time? Is it going to be on time? If it's not going to be on time, how late is it? What kinds of problems are we going to have? Will the software actually work? Will it do what I intend it to do? And so the kind of reports that you want to look for, and yes, I cheated here. Obviously, these reports came out of my tool, but the kinds of things you want to look for, make sure that you can see your static analysis reports, that you can slice it by user, by component, by severity, by category, etc. You need to have traceability reports that show you forward and backwards. So when I look at a requirement, what are the files that are part of the requirement? What are the tests that belong to the requirement? What were the results from the tests that belong to the requirement? What was the code review for the requirement? And at the same token, when I have an auditor, I want to be able to pull the chain from the other direction where auditor might say to me, hey, this test, what was it proving? And I can trace it back to, well, here's the test code, here's the code it was testing, here's the requirement it was testing. So no matter what direction somebody asks a question, I want to be able to answer that question very quickly. I happen to feel like auditors really work much better if you have quick answers to things rather than, well, let me get back to you. And again, the other kind of point is to make sure you have ability to manage tests, not just automated tests that are running, but also the tests that humans have to run inevitably on your software to make sure that you're encapsulating that same information, that the test is run exactly the same way, you know what it means, and you know what it's for. And again, the multi-discipline results to make sure that if you're running static analysis from multiple vendors or two kinds of unit tests, etc., that all those results are bound together in a single meaningful way. So in conclusion, the basic idea is that standards and static analysis, when they're applied properly, become not just quality gates, but actually help you craft code in such a way that errors can't occur. So the cost up front may be a little bit painful, but it also lets you make sure that the error won't be creeping in and you can sleep better at night. And if you have integrated results, then you get better measurement, better traceability, and better management of your project. And as is obvious, the cost of good software is definitely less than even the direct cost of a recall, not to include the lost confidence, lost sales, et cetera, that go on in business. And there's a bunch of places you can follow us, on the web, Facebook, Twitter. I tweet at Code Curmudgeon about various industry things. And with that, back to you, Kurt.
Very good. Thanks, Arthur. Our final speaker is Ashish Kuthiala, the Director of Marketing for Electric Cloud. He brings over 20 years of experience in software development marketing. Prior to Electric Cloud, Ashish served as Senior Director of Global Marketing at ExcelOps, an IT management software company. He served at Hewlett-Packard, the most recently as Director for the Global Product Marketing for HP Software's Network Management Center, where he developed and led a team for two of the company's top enterprise software portfolios. Ashish holds an MBA from Kellogg School of Management and a Master's of Science degree from the University of South Carolina. Ashish?
Hi, thanks very much, Kurt. My pleasure to be here and presenting to you. So I think I'll start with kind of summarizing a little bit what the other speakers said, but not spending a lot of time on, how complex cars have become. But, if you really think about cars now, they've become data center on wheels, right, with millions of lines of code. Some of the cars now have unique IP addresses for nightly software update and, hundreds of electronic controllers that have code in there. Just to give a perspective of the growth of software in cars, I think the first car was a GM in 1979 with about 100 lines of code embedded in there. Today we are looking at about 100 million lines of code in a really smart car. Not all cars, but we're getting there. And about 300 million lines of code is predicted in an average smart car by Frost & Sullivan, an analyst agency. Just comparative numbers, the Dreamliner has about, the Boeing Dreamliner has about 8 million lines of code in there, and the F-35 jet that's been plagued by cost overruns and delays, mostly in the software bucket, has about 35 million lines of code. So 300 million lines of code is, what we're looking at dealing with in an average car. As you look at 300 million lines of code, this brings a number of complexities in there. So where do these 300 million lines of code come in from? As any auto manufacturer, goes to manufacture a car, they work with an ecosystem of automotive manufacturers as well as suppliers. And anything that goes into a car, whether it's engine control or, the electric power steering, etc., everybody who's supplying these parts to the central automaker is actually building software. And every one of these components and the software with it needs to be built, it needs to be tested, and it needs to be released, working with a number of different automotive standards that I'll talk about in just a second, and built to those standards. And as you can imagine in this ecosystem, as all the components start to flow in, and the auto manufacturer who's sitting in the middle starts to integrate them together, he needs to integrate these pieces, he needs to build, test, and release the software according to the standards and regulations that they have to deal with. So, what are some of the standards? I won't go over these again, but just to give you an idea, we're looking at SPICE, ISO 26262, MISRA, and Geneva Alliance. As I work with some of my customers, most of them are working with these standards, if not all of these standards. So we talked about, the number of lines of codes being increased, and an example I would like to present here is NASA today has the strictest standard in terms of the number of errors they allow in their software code before they will allow it for release. And I think it's the strictest in the industry today, with 0.1 errors allowed for every 1,000 lines of software code. If you were to take 100 million line software code base in a smart car, you could expect out of the gate that you could have 150,000 expected bugs, software bugs. And this is a large number. So, there's of course the concern about safety from a consumer point of view, but from the manufacturer's point of view, how do you manage these number of bugs that you can expect to see as you develop software, as you integrate software, and you bring it together? I think an example that all of you are very familiar with is, Fisker, because of software problems, they've had to recall their electric cars. They had to temporarily halt the sales of the Karma, and then this led to laying off of some of their workers and eventually the ouster of their CEO, and they've shut down for the moment. They're trying to repay some of these loans. So the main point of this is very quickly you can get to a situation where software can become your bane. We have all seen these headlines. There's a cost for not solving these problems. So, if I had to summarize, we talked about the different areas where software has an impact on the delivery of a working automobile to customers. But from a manufacturer's point of view, what are the challenges that we have to deal with, right? I think as any software development shop, you need to build the software, and because of the number of lines of code increasing, these builds are very, very slow. So you can often have 10 to 8 million lines of code being built, and software engineers who are highly paid, sitting around waiting for these builds to happen and not being as productive. The testing itself, as you saw with the big matrix, is very slow, complex, and you have to do all sorts of tests. You have to adhere to standards and regulations. You have to integrate all the software processes, all the software code, and the modules. And essentially, this build, test, release matrix is a really, really complex matrix. In my opinion, working with different customers in the automotive industry as well as outside, you need an integrated acceleration and automation approach to bring these pieces together. You need to enable, fast builds, testing across all the software modules and do this fast, you need to introduce, end-to-end automation that helps you do this. As you do this manually, you lose, there are a lot of drop-offs and errors, and there's human-prone error. You need to be able to automate this. But as you do this, you need the visibility across your whole end-to-end process, because without that, everyone is still working in silos that can lead to a lot of errors. So Electric Cloud actually provides a lot of our customers, including some of our key automotive customers, a software delivery platform that ties the build, test, deploy, and release process across the whole automotive software delivery chain. I'll talk a little bit more about this, but this could be the software delivery platform actually orchestrates the entire end-to-end process, accelerating it at the build stage, the test stage, and the release and deployment stage. And it does not require for you to actually replace your tools. It works with your existing development, test, and system tools, your existing application infrastructure, whether it's physical, virtual, or cloud. So, for example, let's talk about the build automation and acceleration that we talked about. As you can see, normal build cycles for software, as I talked about, can take a long build cycle. If you see the top, the bottom graph, the top-hand side of this build graph. But some of our customers, such as GM, Hella, Delphi, and Panasonic, are actually using our build acceleration methods and tools and solutions to tremendously accelerate the software builds that they have to do in order to move on to the next stage of testing and compiling and integrating their software with different automotive suppliers. I see a lot of my automotive customers actually use the V model development in automotive, and where we really play a strong role is on the right-hand side of the V model, where typically manufacturers have a lack of automation and release processes that manage the right-hand side of the V model, and I can talk more about this. So how do we help? Typically with most automotive manufacturers, we provide a platform and a solution with an out-of-the-box automotive workflow that ties together the build, test, and release processes for them across the chain and their suppliers. And you get a template automotive workflow, but you can customize it to your environment specific to what you're doing with your tools. And very specifically, with automotive standards which have to be managed, we help by providing the single platform I talked about to manage the entire software development, the life cycle, and the integration with static analysis tools such as Parasoft, Clockwork, that provides support of MISR SE, MISR SE 2004, and MISR SE++ 2008 standards. In addition to this, with the ability to give you, a test parallelization and comprehensive fast and test cycle, we're able to help you with the standards to make sure you're able to test each and every aspect to meet these automotive standards. Now, testing can take a long time, so our platform allows you to parallelize a lot of your tests, do the resource management for these tests, and ensure that you are getting through your testing cycles much faster in minutes rather than hours, so that you're not missing out on the manageability of these automotive standards. Just wanted to quickly summarize, how some of our customers that we are working with in the automotive industry have been able to, reduce their build times, reduce their testing times, as well as reduce their, time to market with the software that they have to deliver. Dealing with 20, 30, 40 million lines of code today is already a problem, but when we actually start reaching the 100 million, 200 million software lines of code mark, this is going to become a real problem. And if you try to power through this process really fast, what you do want to make sure is that you don't compromise the quality aspect of it, the number of bugs that escape, etc., that we talked about before. If you want to solve both faster time to market and higher software quality, usually that means throwing a lot of dollars and resources in it, which is not an affordability that everybody has today. Just to summarize as key benefits of using the electric cloud solution that most of our customers already are realizing and that you can look forward to are, blazingly fast builds, software builds as you put a lot of software in the embedded electronics throughout the car, etc. Making sure that as you, do that, you have very fast and comprehensive testing and thorough testing across every aspect of this so you don't have number of escaped bugs reaching out to the customers. And finally, you need an end-to-end build, test, release process, platform, and visibility that'll tie this together, give you control, across the whole end-to-end process. That's what I had to share today, Kurt. For more information, you could come to our website at electric-cloud.com or send us an email at automotive@electric-cloud.com. Over to you, Kurt.
Thank you very much, Ashish. We'll get right into the Q&A now. And again, I encourage you to submit those questions and get some input from the experts. Let's start with David Merrill here. There's a question about, can you elaborate a bit on maintaining an approved vendors list within the Polarion tool or a tool in general? Can you track across system versions and projects, end-of-life parts, notification, that kind of thing?
Sure. Thank you, Kurt. The answer to that question is yes. You can absolutely maintain lists of vendors and all of the custom data that you would track with that particular vendor. But really, much more than that, the requirements that you specify for that vendor's delivered component can be maintained in Polarion, can be communicated in a bidirectional way with that vendor over conventional formats or dedicated connectors to third-party software, so that when they deliver the product, you'll be able to trace that vendor to those components and your own test cases which verify acceptance of that particular product or component as it becomes incorporated into your overall product.
Okay, very good. Jessica, here's a question on the security aspects of cars. We talked a little bit about some of the malware. Can you elaborate on how realistic are viruses being able to affect these critical components of the cars? Are these components running real-time operating systems or standard OSs where it's harder to make a virus work, or how does that work? Jessica, you may be on mute.
Oh, sorry, I was on mute. So I would say that theoretically there's a lot of different ways that you can get access into a car's internal network, some of them being more traditional, some of them being less traditional. So, one of the first ways is to actually have physical access, maybe from like a mechanic or a valet, somebody who rents the car, a friend, whatever. They've actually figured out how to attack vehicles now by putting viruses onto CDs. And then when a person tries to listen to that CD, it can infect the radio and then make its way across the network to more critical systems. I mean, at that point, once they get there, they can actually disable the car, listen to conversations, do whatever, their goal is at that time for your car. And so this is one aspect. And then you have another aspect of the wireless side of things, short and long-range wireless technology, some of these techniques that are, being used today, right? You have the cell phones, Bluetooth, all makes these things vulnerable to remote attacks and that are already widely known to criminal hackers. Hackers already know how to do this stuff. And so, I would say that this is becoming, more and more vulnerable within vehicles, especially since they're talking about creating app stores for the cars and things like that. So they've actually done a study where they've tested this out, where they can remotely stop the brakes from in a car from over 1,000 miles away. So these are things that people know how to do, and it's just taking existing hacking techniques that they do now and putting it into a car. So I do. I think it is a realistic problem that people are going to. Right now, I don't think it's like customers are freaking out over the thought of some satellite coming down and stopping their car. But it's definitely, as things start progressing, it's going to become more and more of a concern.
Okay, very good. Arthur, how can I get combined results if I'm using tools from more than one vendor, like static analysis tools? Can you elaborate a little bit on that?
Sure, because that's one of the tricky things is making sure that when you put two sets of results together that they equal what you mean them to be. The classic case is if I have two tools running 50% code coverage, can I call it 100 and call it a day, right?
Right.
The answer may be that you have 50, even though you have it twice. So the trick is that you need some form of a data system. So we maintain that as a central point, and when you execute your tools, you grab the results and you send them to the main database, and the database normalizes those results. And when they come in from multiple tools, it eventually isolates it down to, hey, you have this finding on this particular line of code. So that way, if you're adding up numbers, you actually get one combined number that's real. And if you have, your case of your 250s and it's really 60, you'll see the 60, and you'll actually be able to look at, here's the thing that was done, here's the thing that wasn't done.
Okay, very good. Ashish, so how can I get started to tie together the build, test, release processes across my organization? I think this is a great question where somebody is starting at ground zero. What do they do? How do they tie this across the development, the test, the QA, the project management?
Right. So thank you, Kurt. This is a great question because, typically in software development organizations today, whether it's an automotive sector or even outside, across the different sectors, the build, test, and release teams, and often the teams that support them, are very, very siloed, and they work in their own kind of silos, trying to work, collaborate across these different teams. But the challenge often is, they use their own processes, they use their own tools, and there's no visibility as you go from one silo to the next. And often there's a blind handoff, and that's the main reason why you lead to a lot of errors, the throw over the wall kind of a attitude that happens. Now, I talked about a little bit about in the automotive industry, this becomes even more complex because each one of the suppliers who's working has this problem, and when you bring it all together, you're looking at this problem getting multiplied by a factor of n. To help with this, what we do is, I think I talked about this in my presentation. We start with providing you out-of-the-box templates that tie these processes together. So it's a workflow-oriented, gated process between the teams, and you can use this starting off small in a smaller organization. As you put in and you build more teams on this platform, you can actually add on to incrementally and tie into this process. And the thing that most of our customers like about this is it doesn't change the way that you use your tools today, or it doesn't change the way that you manage your things. It models that and starts to automate this incrementally one by one. And so you could add teams as you go along.
I see. Interesting. Yep. Okay. David, maybe you have a comment on this too. You seem to be talking a lot about life cycle management, which might involve project managers and executive management so they can understand what's going on. How would you view integrating something like what you were talking about into the organization?
Well, actually, the definition of stakeholder within a Polarian concept, and even within the automotive production, is a very broad concept. So our intent is to have a very lean, web-based solution to reach out to any stakeholder, whether they're the highest level executive or consultants or offshore-based testing and acceptance facilities. So we would extend and include build management, incorporate the type of software code analysis being talked about today into all the different functions that have to go on to get the product to market. And along the way, our goal is to make all this information transparently visible to all these stakeholders with the appropriate access rights, but also to make it actionable. And so, we talk, I think there's been a lot of discussion about being able to have blazing fast builds and getting things to market. Well, one of the things that can most hinder getting something to market is the major gaps or silos that exist between the various disciplines. So the engineering teams that are doing electrical circuit board design are different than the engineering teams manufacturing the components and the software teams that are developing the software code.
Right.
By destroying these silos, we make that process transparent to all and improve that cycle as well.
I see. Great. Jessica, can you talk a little bit about static analysis and what some of the common weaknesses they would be able to likely find through that kind of a facility?
So static analysis is usually able to go through a whole comprehensive range of reliability, security, and maintainability issues in the code. So, for example, obviously the coding standards and maintainability. So, matching up with the MISRA rules and standards, looking for dead code, unreachable code, porting issues or unused functions or parameters. Also reliability, such as buffer overflows, injection, cross-site scripting, information leakage. And then you have your security vulnerabilities and concurrency violations, memory leaks, resource management, all kinds of things through the whole gamut there.
Okay. And Arthur, I think when in your presentation, you mentioned something about test management. I wondered is there some kind of automated nightly run reports if you're doing like automated regressions on your software? Is that also part of this, or?
Yeah, and actually that's the common trap people fall into these days is they're using continuous integration and they forget that continuous integration supplements and doesn't replace an automated nightly run. So it's great when you have an automated nightly run because now you say, I know I did a fixed set of events at a fixed time, and I can look at this history over time and see that, well, I'm better than I was. Hopefully, as I'm approaching release, I see that the code is becoming complete, that the tests are passing at a higher level, etc. So, yeah, those kinds of reports are very helpful.
I see. And Ashish, do you agree with that as in terms of the automated nightly regressions? Is that kind of the way the electric cloud system also works? You can identify, report changes, identify problems on a nightly basis?
Oh, absolutely. I think the first and main product that a lot of our automotive customers use is our Electric Cloud Accelerator product. That's core mission is to help and accelerate the software builds. And, often the regression builds that happen at night, is the coming together of all the different code bases and the longer build, the integration builds, etc. And this is the time where, it might take 10, 12, 8 hours for this to be built. And if there's a failure, you're looking at starting the next morning from scratch again. So, you want to avoid this and you want to do it faster so you have faster feedback cycle. And if something goes wrong, where has it gone wrong? What are the reports? Where is it that you want to start looking? We provide a very comprehensive set of reports about this build jobs, both at the individual level and the aggregate level.
Okay, very good. How about David? Do you want to chime in on this?
Yes, thank you. We hear from our customers also the need to elevate the automated tests and the unit and the manual tests to the same level of citizenship or traceability. So again, often there's a silo between automated tests, whether they be based on nightly builds or third-party automated tools, and the manual tests. We want to be able to make them all visible in the same reports and have the same degree of traceability back to their requirement work item artifacts.
Okay, very good. Unfortunately, that brings us to the conclusion of today's eCast. Please remember to do the survey at the end of the presentation here. I want to thank David, Jessica, Arthur, and Ashish for sharing your insights on the automotive industry requirements and solutions. And we at Open Systems Media and the presenters also want to thank you, the audience, for attending and contributing those questions remotely. The eCast will be posted online at the URL shown on your screen within 24 hours, and an audio-only podcast version will also be made available. You can do a web search with the keywords embedded space e-cast and find all of Open Systems Media eCasts available for download as MP3s. Thanks for attending and have a great day.